Alright, so in the last video we went through and we added all the annotations to the elevations. So the next step for this drawing is to do a typical wall section. So as we talked about before, AutoCAD doesn't handle multiple scales real well. It creates a lot of extra work, and whenever I start changing the scale to work on this drawing, if I changed it to 3/4, a lot of times it won't update the size of the text that's put in here, or if I'm looking at a paper space, all this text will end up being a lot different size, or a lot bigger, and just look really bad. So what we're going to do is we're going to create this as a separate file. So just to explain that a little bit further, basically we drew everything in here at a 1/4 inch equals a foot scale. So all the text is this size, and whenever it's printed it's going to be 1/8 of an inch high. So I'm going to print all these drawings at 1/4 inch equals a foot scale. My wall section is going to be at 1/2 or 3/4 of an inch equals a foot. So just to show you a little bit better example of what happens whenever I change the scale, if I change this to 1/8 inch equals a foot, all that text is going to get a lot bigger and it's going to look messed up on the drawing. So I could go ahead and I could work on that. We might do that just to see if we can work through any of the problems. But I wanted you to see basically what happens whenever I start changing the scale of the drawing. So whenever I change to 1/2 inch equals a foot, you can see that basically all this text got smaller and it doesn't look like as much of a problem. So what we would need to do, first of all, we don't want all of this to change, because whenever we actually look at it in our layout, it's going to look goofy. So in our layout, if I click on my viewport, you can see that this is still at a 1/4 inch equals a foot. So the problem really only occurs in model space. So we're going to try to deal with it and see if we can make it work, see how it looks, and maybe play around with these buttons down here a little bit just so that we can see how that changes, what effects those two buttons have on it. So if I go back to 1/4, and this is add scales to annotative objects when the annotation scale changes, if I turn that off and now I change this to 1/8, it still changes those. So we'll leave that on, change this back to 1/4, and this one, show annotation objects. So if I change that to 0 from 1 and I change this scale, they still change. So I basically just have to live with the fact that these are going to change, but they're going to be okay inside the other drawing, actually inside the layout view. Alright, so what we're going to do first off is we're going to copy that wall section. We're going to rotate, and then I'm just going to draw a line, and then I'm going to trim everything from that line. And that's going to be my typical wall section. And I'm just going to have it somewhere down in this area. So the next thing would be to go over to Layout 1, and I'm just going to simply copy my title block and my viewport, and I'm going to bring it over here, and what I'm going to do is click inside of this viewport, and I'm just going to pan over, pressing my wheel in until I find my wall section, and then I'm going to click on this and I'm going to change this to 3/4 inch equals a foot scale and see how it fits. And right now it doesn't fit in this direction, so what we'd have to do is rotate the viewport. So to rotate the viewport, alright, so to rotate this view inside of this viewport, get back out of there, basically what I have to do is use the command MV setup. Couldn't find a button for this anywhere. MV setup, and then I'm going to choose Align, Rotate View, pick a base point to rotate the view, and then I'm going to do -90. Actually, I'm going to start with Align, Rotate View, base point 0. Try this one more time. Align, Rotate View. It's asking me for specify base point in the viewpoint with the view to be rotated. Pick that. Specify angle from base point, 90, and it rotates it that direction. AutoCAD makes that painful. So, then I can basically look at this, and you see it's at 3/4 inch equals a foot scale. If I wanted to, I could probably bump this up to 1 inch equals a foot. Now stretch this viewport out. Bring it up here a little bit. And basically, that is everything at 1 inch equals a foot. So if that fits, I'm going to go ahead and run with that. I would go back over to my model space, and that's basically my workflow. Regardless of what drawing I'm working on, I always find out what scale it's going to be at before I start adding annotations and setting a scale. It's a lot easier to do it that way. So down here, my scale, I'm going to change this to 1 inch equals a foot. And I'm going to come in here and start drawing some text. You can see the text all changed the size in the rest of the drawing. So at this point, I can start annotating this. So before I do that, I'm probably going to add some different detail to this as well. Since we're going to be at such a large scale, we can actually show all the different detail within here. So the first thing I'm going to do is I'm going to draw my insulation underneath my slab. So to draw the insulation under my slab, I'm going to make a new layer. Layer, make A-insu. I'm going to make this color 153 to start. Might be too dark. I can always change it later. And I'm going to offset this down 2 inches for the styrofoam underneath. And I'm going to draw a line right there. And I'm going to hatch this. And I'm going to come up here and I'm going to use user define. And I'm going to make the angle for this 45. And I'm going to double this as well. So somewhere in the properties here I have the option of doubling it. And that's basically what it's going to look like. I might give it a little bit less spacing. We'll try 1.5, about 1.25. So that's going to be my styrofoam insulation. In addition to that, I'm going to have styrofoam insulation on the inside as well. So I'm going to offset 2 inches, trim that, and I'm going to, this is my insulation layer, so I'm going to once again hatch, select that, hit enter, and I'm going to use my match properties to change my layers and my hatch pattern. So now I have insulation on the foundation and under the slab. So the next step would be to draw insulation here and here. So in here we're going to have rock wool. Between the studs and the cavity we're going to have rock wool bats. So we're going to use the same thing that I would use for fiberglass bats, and what it is a line type. So I'm going to make another layer, and I'm going to call this A-insul-rock, and the line type LT is going to be batting. By doing that this way, it's automatically going to load that line type. So I'm going to draw the line, and this is what it's actually going to look like. So I'm also going to set the color for that layer, and we're going to make it 14, and whenever I go to put this in, this is basically a line, so it's going to have an endpoint. I'm going to drop that endpoint right there, and then I'm going to take the other endpoint to right there. Right now it's way too thick, so the easiest way to do this would be to come over here and start playing around with the line type scale. I'm going to type in 0.5, see where that gets us. 0.4. 0.3. 0.3 works pretty nicely. If I wanted to, I could figure out exactly what this is. And I'm going to end on 0.33. I'll leave it at that. We're going to have cellulose up here instead of rock wool. Maybe we'll just use 12-inch rock wool bats up here. So if I wanted to do that, I could just simply copy this, and I could offset this bottom line up 12 inches. I could rotate this, and I could come in here, put that right there, stretch this over, and then I could change the scale of this in my properties to make it fit. And I'm just trying different ones, getting it close. And I ended up with 1.2. So the problem with this is, the real problem in real life is, if I'm going to use a 12-inch bat up here, I'm basically going to have to end that bat somewhere back here, because it's not going to go past out from the roof. So in here I have to start compressing it and stuffing it in there, and a lot of times what happens is I have the vented soffit out here, and I have a ridge vent up here, and there's supposed to be air movement that goes through this truss cavity the whole way from down here up to the ridge vent to keep this roof cool at all times, not only to extend the life of the shingles, but to prevent ice dams and to prevent basically what happens is, if there's heat in here, the heat rises, slowly makes it through the insulation, heats up any snow that's sitting on top of this roof, and then as it melts, it rolls down the roof, and once it gets to this point, this roof, this part of the roof, the tail, has no heat under it, so it's very cold out here. The water refreezes here and starts to make icicles, and it starts to work its way back up through. It wicks its way, and a lot of times it'll find its way into this wall cavity and slowly rots that wall without anyone knowing it. So you don't want to block that airflow, so I don't want to stuff this insulation in there. So there's a couple different things that we could do. I could just reduce the amount of insulation out here, which isn't the best option. What I could also do, if I just copy this, a lot of times what we'll do is have the truss designers build a heel into this truss, an energy heel. So if I wanted 12 inches, I could basically move this top cord up 12 inches. I wouldn't have to do 12 inches because I already have 3.5 here, so I'll do 8.5. I'll move it up 8.5, and I basically end up with a truss, and I have to change my line type. A-truss. And I find that, set that current. I basically have to draw something like this. And that's how the truss would look. And then I would just have to extend this OSB up past there. And now, whenever I put my insulation in here, I can run it the whole way out, having continuous insulation the whole way through the wall, the whole way out where I need it. And I also have about an inch here for an airspace. So I have a vented soffit, basically a vinyl soffit that has holes in it. The air moves up through here, goes through the cavity, and then exits, keeping the roof cool. So this is a pretty good situation. It does add cost to the building. It adds cost to the trusses, plus you have to have OSB that is longer than 8 feet. We were already extending it past the slab a little bit here, so the 8-foot OSB wouldn't have worked anyway, so we would be able to overlap those, tying the roof. And so if we were just going to look at this, if I draw a line out here and I offset this up 8 feet, my OSB is going to end right here. So the second piece of OSB is going to go from this point up to there. And the nice thing about this is it ties this roof system together with this wall system. So in case of tornado or hurricane, you have a very, very strong roof and wall structure. Now if I could do the same thing down here, extend this past even further and secure this to this slab, or if this would be a wood structure, now all of a sudden I have my wall tied together with my floor here, and I have my wall tied together with my roof here. So it's a very smart way of laying this out. And I don't see a whole lot of contractors doing this. What they'll do instead is they'll cut, first of all, they would have this whole thing sitting back a ½ an inch so that my OSB lands right here, which is going to cause a problem with the water wicking, but it gives them the option of ending this with an 8-foot piece of OSB. So this is something that you have to call out in the drawings and show that. So the problem now becomes, if we decide that we want to roll with this, none of this works anymore. All of this has to change. because whenever I move this over here, line it up with that, now all of a sudden, and we'll just do this a little bit differently, I will copy this up here, I'll rotate it, move this to from a common point to a common point, move previous, bring it down here. At this point I would mirror it from my ridge line. And just to show you how this all works out, move these out of the way. These aren't going to be in our viewport anymore, by the way. Bring this back down here, line up the bottom of the footing with the bottom of the footing, move previous. Now whenever we look at this and we project our line over, now all of a sudden this roof is up higher. Not only that, our fascia is up higher. So none of this works out. So a lot of times, if I'm going through and I'm doing a design, most of the time what I'll do is I'll have all the details of the wall section worked out before I start doing elevations. So the debate is whether to do this or not. So if I was doing a house design, I would definitely add this as a feature because I'm very concerned about losing heat. The idea with this garage is it's only going to be heated to a very low temperature, around 50 degrees, basically keeping it from freezing, and we're not really too worried about it. It's probably going to be heated only on occasion, and we're not as worried about it, so we're just going to forget about doing this raised heel. And I wanted you to understand that if you're doing a residence, this is a really good way of doing the design. So I can go through and delete this, and I can move these back over, and the one I'm going to use is this one. And I'm just going to leave it like this, and I'm going to start drawing the rest of the stuff. So right now I have my insulation on my foundation, under my slab, in my wall cavity, and in my ceiling. So the next step would be to start adding some more details into this. So I could show my parging just by offsetting 0.25 inches, and I'll have my parge extend the whole way up to this point, and right now it's on this foundation layer. I think I have one for parge. So A-parge, and trim that line out. Down here, what I want to do is I want to create a little cove that would shed the water away from that. So we're actually going to put a drain in for this garage, and we're going to put in a radon vent for this garage. So I think we'll actually put the radon vent up above, but for the cove I'm just going to draw an arc from that point to a random point. I click there, I trim this, and then I just kind of fudge that in. And I'll match properties, and that's basically a cove to shed the water outward. So the next step would be to draw my drain. I'm going to use a forma drain, and a lot of these things we would definitely put in for a house basement. So I'm going to make a layer, make a dash drain, color, we'll put that on color 10, and forma drains, I'm going to make it 2.5 inches from there, draw the line out here. They have a channel running through the middle, and they have a 4-inch drain connected to the middle of this as well, or from the bottom. So I'm just going to kind of fudge this drain in. So I'm going to draw that line, 2-inch drain, and this is what it would look like connected onto there. So it becomes kind of confusing what this actually is. So to make this look like a piece of pipe, what I can do is I can draw an ellipse, and before I do that I'm going to draw a line across here and draw an ellipse, and I'm just going to pick the midpoint to the end point. I'll delete that. I'll copy this up here, and I'm going to add that line back in, and I'm going to trim that out. And that's basically what the end of our pipe would look like. And to make it look even more realistic, I'd probably fudge this a little bit. Trim that out. And leave it look like that. Match my properties. And I have my forma drain with my pipe coming off. Just to make this look better, I'm going to move this up to the middle, because it looks a lot better and it makes a lot more sense coming off of there. So the next thing after this, in order for this forma drain to work properly, this whole part of the foundation should be backfilled with 2B crushed stone. So crushed limestone, not dirt, not shale. So I'm basically going to add this in as a hatch pattern, and in order to do that, I'm going to stretch this out of the way first off, and I'm going to just add a line down here, line there, and I think I had a layer in here just that was supposed to be a light A' thin. So I'm going to put it on that layer. It just happens to be the same as these ones. Trim these out for right now, and draw that one back in. And I'm going to make a new layer. Layer, make a dash gravel, color, let's make this 241, and we're going to hatch, pick points, and we're going to grab a pattern, and we're going to look for our gravel hatch. And we're going to change the density of this a little bit bigger. Maybe 2.25. Hit enter and leave it at that. The next one that I'm going to add in is going to show the ground. So I'll draw another line right here, and I'm going to match my properties. And this one, I'm going to make a layer A dash earth, and we'll give it a different color. How about 15? And I just changed that. Layer, make A dash earth, color 15. And again, I will hatch this, and I'll find the earth hatch. Change the density. Leave it like that. And actually, for undisturbed earth, we're going to change this angle back to 0 and show it like that. And then I would delete that line, and I would delete that line, and break this line off of there, and I would pull this back to there. And then I would need to go through and clean this up a little bit. So I'm going to hatch that, match my properties, delete that line, delete that line.